Imagine a world where the air itself is deadly, where breathing would kill you. Now imagine that the same molecule that was once poison became the foundation for forests, brains, and everything that breathes today. This is the story of how tiny microbes changed a planet. This episode is brought to you by InfiniteCosmos. Earth formed about 4.5 billion years ago. For the first 2 billion years or more, the atmosphere was anoxic, rich in methane, carbon dioxide, and volcanic gases, with almost no free oxygen. Life began in those oxygen-free seas, and early metabolisms were adapted to that chemistry. Any oxygen produced was quickly consumed by chemical sinks, so the air stayed hostile to oxygen-dependent life. Then cyanobacteria appeared. These microbes used sunlight to split water and released oxygen as a byproduct. They built layered mats called stromatolites and slowly pumped oxygen into the oceans. At first, oxygen reacted with dissolved iron and volcanic gases, forming thick banded iron formations and preventing atmospheric buildup. Around 2.4 billion years ago, a tipping point arrived. The sinks became saturated, and oxygen began to persist in the oceans and atmosphere. Geologists call this the Great Oxidation Event. The rock record, declining banded iron formations, the appearance of red beds, and shifts in sulfur isotopes, preserves this planetary transformation. Rising oxygen was both destructive and enabling. Many anaerobic microbes suffered or died, but oxygen also made aerobic respiration possible, yielding far more energy per unit of food. That extra energy allowed cells to grow larger, specialize, and support internal complexity. Over time, this helped drive the rise of eukaryotic cells and the endosymbiotic origin of mitochondria, which further boosted cellular energy budgets and opened the door to multicellularity. Across hundreds of millions of years, these changes accumulated. Tissues, organs, animals, plants, and eventually ecosystems like forests and reefs. Oxygen also helped form an ozone layer that shielded life from harmful ultraviolet radiation, making life on land more viable. We reconstruct this story from rocks and chemical fingerprints. Stromatolites, banded iron formations, red beds, and isotope records. Many details remain active research questions, but the broad arc is clear. A tiny microbe's waste product rewired Earth's chemistry and made complex life possible. If you enjoyed this deep dive into Earth's oxygen revolution, subscribe to InfiniteCosmos for more origin stories.